All right, everybody, thanks for coming back today. Today we're going to talk about derivatives and how to take them using a couple basic derivative rules. Okay, this is really the first time we're going to start being able to use some shortcuts to take derivatives in calculus. So the main rule we're going to learn today is called the power rule, and that's something we'll use a ton the rest of your curriculum. And we're also going to talk about a couple other rules, the constant rule, the sum and difference rules, and the constant multiple rule. But let's start today with the power rule. Okay, if n is a rational number, the function f of x equals x to the n is differentiable, and the derivative of x to the n is simply n times x to the n minus 1. You take the power and bring it out in front, and it becomes a scalar multiple, and then you lower the power by 1. So a special case of that would be x. Think of x as x to the first power, right? If we use that rule, it becomes 1x to the 1 minus 1, or 1x to the 0. And what is x to the 0? It's just 1, so it's 1 times 1, which is 1. Important notation here, though. You see the d dx. That means the derivative of this function with respect to x. If this x changes to something else, our derivative would no longer just be 1. And we'll talk about that later on. The constant rule, the derivative of a constant function is 0. That is, if c is a real number, then the derivative of any constant c is 0. Okay, think about that, what that means here. Think about the graph of y equals c, right? So if we drew a quick graph, this line y equals c, remembering that the derivative is just a slope, well, what is the slope of this line? It's just 0, right? So derivative of that would just be 0 everywhere. When finding the derivative of a function, we always take the derivative with respect to a variable. If the function's variable and the respected variable are the same, you do not need to write that part. If they differ, then it must be written. What does that mean? Let's take a look at example 1. It says y equals x, and we're going to take the derivative 3 different ways, with respect to x, respect to y, and respect to t. So with respect to x, so this is like y to the first, right? I'm just going to rewrite this. It's y to the first equals x to the first. Using our power rule, it's 1 y to the 0 times the derivative of y, which is dy, respecting x, which is dx. So it's 1 y to the 0 dy dx. And on the right side, we have 1x to the 0, and then the derivative of x is dx, respecting x is dx. So simplifying this, we get 1 times y to the 0, which is 1, times dy dx, which is just dy dx, equals 1 times 1 times dx dx, which is 1, so it's just 1. So the derivative of y with respect to x is just 1. And that's what we kind of covered right here. But what if we're not respecting x? What if we're doing these with respect to y? So again, we have the same function. I can't grab it here. There we go. So we have 1 y to the 0 dy, but this time we're respecting y, so dy, equals 1x to the 0 dx, but this time we're respecting y, so dy. So now we have 1 times 1 times 1, which is just 1, equals 1 times 1 times dx dy, which is dx dy. So this time we have dx dy equals 1. Okay, and then still a third option here is if we're respecting t. Now we can respect any variable we want. I'm just choosing a couple here. So the derivative of y to the first would be 1 y to the 0 dy, but we're respecting t, so dt. That equals 1x to the 0 dx, respecting t, so dt. So that becomes 1 times dy dt equals 1 times 1 dx dt. So we have dy dt equals dx dt, which we can rearrange and end up getting back to dy dx equals 1. But I'm just trying to show you the different ways we can take derivatives respecting different variables. So let's take a look at example 2 here, and we're going to go a little quicker this time. So first, respecting x, the derivative of y will be 1 dy dx. The derivative of x using our power rule here is going to be 2x to the first dx dx. But we don't need to write the dx dx since it's 1, so it's just 2x. And then with respect to y, so it's 1y dy dy equals 2x dx dy. And that gives us 1 equals 2x dx dy. And if we divide by 2x, we get 1 over 2x equals dx dy. And now respecting t, here we get the derivative of y with respect to t equals 2x times the derivative of x with respect to t. And I wrote this one wrong right here. It's supposed to be dt. So dy dt equals 2x dx dt. And there's really nothing we can do with that. That's going to be our final answer there. So this is a quick note on how to do this respecting different variables. Usually we are going to respect the independent variable, which is normally going to be x. Okay? So here, as to find the derivative of each of the following using our power rule. So the first one, we write this as f prime of x, and using our power rule is going to be 5x to the fourth dx dx. But we don't need to write the dx dx because it's 1. So 5x to the fourth. For b, we can't really do this yet, so we got to rewrite this as x to the 3/4 power, and now we can use the power rule. So g prime of x would be 3/4 x to the, and then 3/4 minus 1, which is negative 1/4. Now normally we don't like to have negative exponents in our final answers, so we need to rewrite this as 3 over 4x to the 1/4. And C. Now there is another way to do this, which we have not learned yet. We'll talk about that in a lesson coming up shortly. It's called the quotient rule, but we don't know that yet. So first thing we got to do for this one is to rewrite this. And this is actually the better way to do this problem anyway. The quotient rule, while it would work, is not the best way to do this problem. It's much easier to do it this way. All right, so our derivative will be dy dx equals negative 3x to the negative fourth. And again, we don't like the negative exponent there, so rewrite as negative 3 over x to the fourth as our final answer. All right, the constant multiple rule basically just says if you have a constant multiplying a function, you can just ignore that constant while you're doing the derivative and then multiply it by the derivative at the end. So for a, taking the derivative of this one, basically ignore the 2, and our derivative would be y prime or dy dx, either one is fine, 2 times 7x to the 6th dx dx. And simplifying there, we have 14x to the 6th. Part B, we're going to rewrite this like we did in the previous question, so 3x to the negative 2. So g prime would be negative 6x to the negative 3. And rewriting that would be negative 6 over x cubed. C, we're going to rewrite the numerator here. Actually, we're going to rewrite this in a couple different ways. I'm going to take the over 8 and make it a 1/8 x to the 5/6. So now our derivative would be 1/8 times 5/6 x to the negative 1/6. Simplifying that and rewriting, we would get 5 over 48 x to the 1/6 power. All right, so you can see here in A and B, they look very similar except with the parentheses. So let's take a look at A. Again, we can think of this as 3/8 x to the fourth, right? So then y prime would be 3/8 times 4x to the third. And simplifying that, we would get 12/8 or 3/2 x to the third. Now this one looks similar, but we have those parentheses around it. So really what we should be doing first here is multiplying out 3 to the fourth, x to the fourth. 3 to the fourth being 81. And again, we can think of this like this, 81/8 x to the fourth. So then our derivative, y prime, or dy dx, would be 81/8 times 4x to the third. And simplifying that, we would get 81/2 x to the third. So you can see how just throwing parentheses in makes a big difference in our final answer. For C, we want to rewrite this first like this, 9/7 times x to the -2. So then our derivative would be -18/7 x to the -3. And rewriting that would be -18/7x cubed. Now D looks very similar to that. However, we have those parentheses there, so I would start by rewriting it like this, 9/49x squared, or 9x to the -2/49. So our derivative would be -18x to the -3/49, or -18/49 with an x cubed in the denominator as well. So -18/49x cubed. All right, what if we're adding or subtracting multiple terms? Nothing changes. We just take the derivatives individually and then add or subtract them at the end. Okay? So for part A, the first thing I would do, now again, there is another way to do this problem called the quotient rule, but we have not learned that yet. We'll take a look at that in an upcoming lesson. So for this one, what we're going to do is we're going to break this up into 3 terms. So we can divide each term by that denominator. And then rewriting that, we get x squared minus 4 plus 5x to the -1. So then our derivative would be 2x. The derivative of -4 is 0 minus 5x to the -2. So then our final answer would be 2x minus 5/x squared. Or sometimes, if you see this as maybe a multiple choice type question, you might need to get a common denominator there. So our final answer would be 2x cubed minus 5/x squared. Either of these would be fine. If it was a free response question, I would definitely stop here. All right, part B, there's another way to do this problem called the product rule, but we don't know the product rule yet, so what we'll have to do is we'll have to multiply this out first. X squared times x is x cubed, x squared times -3, 1 times x, and 1 times -3. And then our derivative, 3x squared minus 6x plus 1. And that's it. Nothing else needs to be done for that one. Question C, I'm going to start by rewriting this kind of like how we did in the first one. 2x squared, but I'm also going to write the root x as x to the 1/2 minus 3x over x to the 1/2. And then rewriting again, we have 2x to the 3/2 minus 3x to the 1/2. And now we can apply our power rule and our sum and difference rule. So the derivative would be 2 times 3 halves, which is just 3, x to the 1 half, minus 3 times 1 half, which is just 3 halves, x to the negative 1 half. All right, so our final answer would be 3x to the 1 half minus 3 over 2x to the 1 half. And if you want to take those 1 halves and turn them back into radicals, that's fine, or you can leave them as exponents like we have there. All right, so we've been talking a lot about tangent lines this year. Now we have a quicker way to do tangent lines. So question A says, write the tangent line to a function at the given point. What do we need to write a tangent line? We need a point and a slope. This is a great problem because it already gives us a full point. All we gotta do is find a slope. How do you find a slope? Take the derivative. So the derivative is 1 minus 4x, which means the slope everywhere is 1 minus 4x, right? But we don't want the slope everywhere. We want the slope at x equals 1. So we're going to put 1 into there, and we get negative 3. So our slope is negative 3. So now using this point and this slope, we can write our tangent line out of y minus negative 1 or y plus 1 equals negative 3 times x minus 1. All right, part B is another one. Kind of the same question here. If you feel comfortable doing this, you can pause this video and try this problem on your own. And then when you're done, you can come back and check your answer. So here we have a function and just an x coordinate. So we don't have the full point and don't have the slope. That's okay. We'll be able to find them both pretty quickly. First, let's find the point. So to get the point, we just want to put 1 into our equation. That's 2 times 1 or 2. So our point is 1 comma 2. All right, now to find the slope, we're going to take the derivative. Remember, 2 root x is the same thing as 2x to the 1 half. So it's 2 times 1 half x to the negative 1 half. Or 2 times 1 half canceling out, just 1 over x to the 1 half, or 1 over root x. So an f prime of 1 would be 1 over root 1, or 1. So our point, our slope, our point slope form is going to be like that. Now, again, you don't need to write the 1 there, obviously, so you just do y minus 2 equals x minus 1, or if you really want to go far here, you can put it in slope-intercept form. Any of those answers would be acceptable. The last thing we're going to talk about today is horizontal tangent lines, okay? This is a very important topic in the next chapter when we have to start finding extrema. But for right now, let's just talk about what a horizontal tangent line is and how to find it. So at what point does the graph of y equals x squared plus 4x minus 1 have a horizontal tangent line? If it's a horizontal line, that means the slope is 0. In other words, the derivative is 0. So this right here tells you you're looking for when the derivative is 0. So we're going to start by taking the derivative. And this question is asking, when is it 0? Use your algebra skills to solve. And we get x equals negative 2. So this graph has one horizontal tangent line, which makes sense. What kind of a graph is this? This is a parabola, right? I don't know what it looks like, but I know at negative 2, it's got a horizontal tangent line. It probably looks like this. Or maybe it's moved down here. I'm not sure, but I know it's got a horizontal tangent line at x equals negative 2. And our last question of the day here says, given the function f of x equals x cubed plus kx and a line y equals 6x minus 2, find the value of k so that the line is tangent to the function. All right, so when we start talking about tangent lines, again, we know we're going to want the derivative. We know we're going to want the slope everywhere. So let's start by taking the derivative of f. That's going to be 3x squared, and k is a constant, so plus k is our derivative. Okay? And I know that the derivative, which is the slope, must equal the slope of that line, which is 6. Okay, I also know at this random point that we're talking about here, this function must have the same y value as this function. So here we have a system of equations, which we can solve in a couple different ways. I'm going to start here by solving this equation for k and then putting it in this equation. So solving this equation for k, I get k equals 6 minus 3x squared. And if I put that in here, my equation becomes x cubed plus 6 minus 3x squared times x equals 6x minus 2. Now it's just a matter of solving this equation using our algebra skills. Combine like terms here, I get negative 2x cubed subtracting 6x from both sides, I get negative 2x cubed equals negative 2. Divided by negative 2, I get x cubed equals 1. So the cube root will give me x equals 1. So let's go back and answer the question here. The question says to find the value of k. And we know that k is equal to 6 minus 3x squared. So put that 1 in there. We get k equals 6 minus 3 times 1, or 3. And that'll do it for today's lesson on the power rule. Hope to see you again next time.